Alright, so our answers here would be x is equal to 2.75, or 2 and 3/4. Over here would be y is equal to 4. And I believe for these two, you just set them equal to each other. And for this one here, you would simply set them equal to each other, I believe. Hold on, let me double check. So we have JFK, and KFG, right? Because diagonals bisect the opposite angles, so that means those two angles are equal to each other, right? And then we know that all the sides are congruent, so we could set these two sides equal to each other as well. Now, we're down here, and we're looking at the condition for rhombi and squares. If the diagonals of a parallelogram are perpendicular, then the parallelogram is a rhombus. So we can use this to prove that a parallelogram is a rhombus if the diagonals are perpendicular. And then if one diagonal of a parallelogram bisects the pair of opposite angles, then it is a parallelogram. Like in this case, we only need to show that one diagonal bisects the pair of opposite angles in a parallelogram. And then lastly, if one pair of consecutive sides of a parallelogram are congruent, then the parallelogram's a rhombus. So we could use all of these to prove rhombus. And if a quadrilateral is both a rectangle and a rhombus, it's a square. Okay, so let's go ahead and try to do this proof here. And it's been a while since we've done proofs, but of course we start with a given. So we're going to say J, K, L, M is, and I'm going to use the parallelogram symbol there. And we also have triangle JKL is isosceles. So number one is given. Right. So if JKL is isosceles, then that means that these two sides are congruent, right? Via the definition of isosceles triangle. And then you can notice here that these two sides are consecutive sides, right? So we can go straight to the parallelogram as a rhombus. So this is kind of an easier proof, right? So let's go. Number two is going to be JK is congruent to KL. Or line segment JK is congruent to line segment KL. And then the reason here is going to be definition of isosceles. Isosceles triangle. And then from there, we can go straight to the parallelogram's rhombus. We can go straight to JKLM is a rhombus. And the reason is going to be this one here. So I'm going to put here consecutive sides are congruent. Consecutive sides congruent. And we're done. Right? All right. So we're flipping over, and then we have this problem here. And so this problem here is determine whether the parallelogram, so we're given it's a parallelogram, and we have these vertices, whether it's a rhombus, a rectangle, square. Right? We don't need to prove it's a parallelogram because we're already given that. But we need to show that it's rhombus, rectangle, or square. So what we first want to do is roughly graph it. Right? So we're going to go -7, -2 is going to be here. This is J. And then we go to 0, 4 is going to be up here. This is going to be a K. And then we have 9 and 2 is going to be my L. And then my 2 and -4 is going to be my M. Right? So we have this shape that looks something like that. And we could tell right away that it's definitely not square, right? And we could tell right away that it's definitely not rectangle, but it's possibly a rhombus. And so how do we prove if a parallelogram is a rhombus? If its diagonals, we're down here. If the diagonals are perpendicular, right? Or if we have two consecutive sides congruent, then we could prove that it's rhombus. So yeah, I think two consecutive sides congruent would be the easiest way to do this, right? Because we could just do distance formula on JK and KL, and if those are congruent, then we're done, right? So let's go ahead and do that. Yeah, let's go ahead and do that. Staying calm. Okay, so let's go ahead and do that. It's distance formula, your favorite, I'm sure. So I'm going to do distance of JK is the square root of, what's it? It's 4 plus 2. No, I'm sorry. It's going to be x2 minus x1. So it's going to be 7 squared plus y2 minus y1. So it's going to be 6 squared. So that's equal to square root of 49 plus 36. So that equals to 70, 85, square root 85. Okay. And then we're going to find the distance between K and L. K and L. So we'll say square root of 2 minus 4, so it's negative 2 squared, plus 9 minus 0, it's going to be 9 squared. So it's going to equal to the square root of 4 plus 81. It's equal to square root 85. So, because of this, we can definitely say that since JK is congruent to KL, that the shape is a rhombus, that the parallelogram is a rhombus. Right? So, what is this? So we could say JKLM is a rhombus. And so these problems here, and here, 1 and 2, are going to be solved that way. First, you're going to graph it. Then you're going to eliminate whether it's a square or a rectangle, right? Because squares and rectangles have 90-degree angles. This one obviously does not. And then you're going to either prove it's a rhombus, and you could prove rhombus by the angles of the diagonals that they make to each other. That's a little bit more difficult. You could also prove it by showing that one diagonal, bisects the pair of opposite angles. That's a little bit difficult as well. So this one is probably the way you want to go, is to show that two consecutive sides of the parallelogram are congruent, and then you can show rhombus, and that's distance formula, just like what we did, right? How would you prove if it's a rectangle? You could prove rectangle by diagonals congruent. If the parallelogram's diagonals are congruent, then it is a rectangle. Right? How could you prove square? You can prove square by showing diagonals congruent, meaning it's a rectangle, and all the sides are congruent. Right? So if you have a shape that has 90-degree angles, or looks like it has 90-degree angles, and you want to show that it is a rectangle first, and then you can show that it's a rhombus. A square is a rhombus and a rectangle, right? So to show that it's square, you would want to prove that it's rectangle, and you would also want to prove that it's rhombus. And then once you're there, then you can go straight to the fact that the parallelogram is a square. Okay. And we're going to prove rhombus by two consecutive sides congruent. We're going to prove rectangle by diagonals congruent. Yeah, that's it. So good luck on 1 and 2, and we'll go over the proof here together in the next video.